In this video, we're going to work example problems related to congruent triangles. So what exactly is the meaning of congruence and congruent triangles? And what are the different methods that we can use to show that two triangles are congruent? So let's get started. For the triangles shown, we can express their congruence with the statement triangle ABC is congruent to triangle FED. By reordering the vertices, express this congruence with a different statement. So what they're talking about here, what they're wanting to illustrate here is that we know that we could have a figure, any figure like this rectangle, for example, with vertices W, X, Y, Z. And as far as naming this figure, it doesn't matter where we start or the order that we put the vertices in, as long as we walk in order around the figure without skipping over a vertice. But like where we start or the direction that we walk around the figure doesn't matter. So we could call this rectangle WXYZ. We could call this rectangle YZWX. It doesn't matter. We just can't say something like rectangle XZWY. That's incorrect. Because here we skipped, so XZ, we skipped over Y. So it's not clear what the sides are, is the issue. And so with that, what they're saying here in this problem is that we're free to name these triangles whatever we want. So there's multiple ways to state this congruence here. Because, okay, this is triangle ABC, but we could call this triangle CBA. For example, that's fine. Okay, but we know that this triangle is congruent to this triangle. So by naming this triangle CBA, well, now we need to, the order actually matters here, because if you're going to state that two figures are congruent, you need to, it's important that you match up the corresponding vertices correctly. That's very important. So here now, we can't now, in this case, we could arbitrarily name this whatever we want. But now when we're saying that this figure is congruent to this figure, this triangle, now we can't just arbitrarily name this triangle whatever we want, because we have to make sure that, okay, the first letter is going to correspond to C. The second letter is going to correspond to B and to A. So what corresponds to C here? Well, that's going to be D. And we can see this visually, but we could also, if we didn't even have a figure, we could come to the original statement and we could see that C corresponds to D. And then B is going to correspond to E. And then A is going to correspond to F. So there's another way we could state this congruence. Both this and this are equivalent statements. Okay, same figure, different question. It says, with corresponding angles indicated, the triangles shown are congruent. Find the values for A, B, and C. So these A, B, and C. So since we know that these two triangles are congruent, we know that all of the it's the exact same triangle, just reoriented differently. It's the exact same triangle. So all we need to do is figure out, okay, if they're the same triangle, then what side does this correspond to? What side does this correspond to? And once we figure out what corresponds to what, we know that their measures are the same. So now we can visually get a sense for what corresponds to what. This looks to correspond to this, and this to this, and this to this. But to make this more official, it would be nice if they gave us a statement of the congruence and we could match up the side lengths. But with triangles, we can use a trick with triangles. So since these two angles are corresponding here, then we know that the sides opposite those angles are going to correspond. So in that case, we know that B is equal to 8. Same here. These are going to correspond, so we know that A is equal to 10, and then all that's left is that means that these two sides have to be corresponding. That's the only remaining pair, so C is equal to 11. Okay, same figure, new question. With corresponding angles indicated, find the measure of angle A if the measure of angle F is 72 degrees. Okay, well, it shows us that angle F corresponds to angle A, so they're congruent. So if the measure of angle F is 72 degrees, then the measure of angle A has to be 72 degrees. They're corresponding in regards to congruent triangles. Well, I guess it doesn't officially state that these two are congruent, but it shows us with the symbol that these two are congruent. So maybe the triangles aren't congruent, but the angles are congruent for sure. So in that case, then the measure of angle A and the measure of angle F are equal, so the measure of angle A is 72 degrees. Okay, with corresponding angles indicated, find the measure of angle E if the measure of angle A is 57 degrees and the measure of angle C is 85 degrees. So they don't make an official statement that the two triangles are congruent, but they do say that, okay, this angle is congruent to this angle is congruent to this angle. So let's see. The measure of angle A is 57 degrees. That means this is 57 degrees. The measure of angle C is 85 degrees. Okay, so, and we're trying to find the measure of angle E. Well, we can find the measure of angle B because we have two angles here. So 85 plus 57, 142. So 180 minus 142, 38 degrees. So this is 38 degrees. Okay, but angles B and E are congruent. So that means E has to be, the measure of angle E is 38 degrees. Consider triangle ABC and triangle ABD in the figure shown. So triangle ABC and triangle ABD. By the reason identity, angle A is congruent to angle A and segment AB is congruent to segment AB. Yeah, so it's by reason identity because they're the same angle and side. So for both of these triangles, angle A is the same angle. So it's that reflexive property or identity. And that when you're comparing the two triangles, when you're comparing triangle ABC to triangle ABD, you're saying that angle A is congruent to angle A. It's the same angle. And similarly, side length AB for both triangles is the same. So they're both congruent. All right, so if segment BC is congruent to segment BD, so in that case, what they're saying is that this is congruent to this. With that, then, can you prove that triangle ABC is congruent to triangle ABD? So, okay, what we can do is, comparing the two triangles, again, ABC to ABD, we have these two side lengths are congruent. We have these two angles are the same angle, they're congruent, and we have this side length is congruent to itself, just like this angle is congruent to itself. So, okay, we've got two side lengths and an angle that are congruent. All right, but that's not enough to say that we have to use one of the congruence criterias, because we have to see where is that angle relative to the two sides, the two congruent sides. So what we can see is we've got, looking at triangle ABC, we've got two side lengths and an angle, but the angle isn't included between the side lengths. And looking at triangle ABD, we can see it's the same idea. It's a side-side angle. So side-side angle is not one of the congruence postulates. We have to have the angle included between the two sides that we know. So no, we can't prove that with just this information. We can't prove that triangle ABC is congruent to triangle ABD. And just visually, we can see that that's not going to be the case anyway. Triangle ABD is not going to be the same triangle as triangle ABC. So with part B, it says if yes from part A, then by what reason is the triangle congruent? Well, the answer to part A was no. In a right triangle, the sides that form the right angle are the legs. The longest side opposite the right angle is the hypotenuse. Some textbooks say that when two right triangles have congruent pairs of legs, then the right triangles are congruent by the reason LL, like leg-leg. In our work, leg-leg is just a special case of one of the postulates in this section. Which postulate is that? Yeah, so we can think about this. What they're saying is if we have two right triangles, okay, and we're wondering if these two are congruent. And we know that two of the legs are congruent. Now, it said that based on our knowledge that we learned in this section, can we say that these two triangles are congruent? Yes, because look, it's a right triangle, so we know the two right angles are obviously congruent. So what that results in, since we have the two legs matched up as well, that's side angle side congruence, the side angle side postulate. So this LL, this leg criteria for right triangles, you can see how you can prove that using the side angle side postulate. In triangle ABC, the midpoints of the sides are joined. So here's this triangle ABC, and the midpoints of these sides are joined. What does intuition suggest regarding the relationship between triangle AED and triangle FDE? So triangle ADE and triangle FDE. We will prove this relationship later. So yeah, intuition suggests that these two triangles are congruent. They look like the same triangle, just one is flipped vertically relative to the other, right? You take triangle ADE and just flip it vertically about a horizontal line, it looks like you're going to get triangle DFE. All right, what does intuition suggest regarding triangle AED and triangle EBF? Well, same thing. It looks like they're the same triangle, but visually it looks like that's the case, but I mean, it doesn't. We know for sure that it's not like angle A has to be equal to angle B. So I don't know. Okay, so these two sides are the same. These two sides are the same. These two sides are the same. I don't know. It looks like all of these triangles are congruent. That's what it looks like visually, just at first glance. But again, it's also kind of confusing when you think about how it's not like angle AC and B are going to be the same. In general, they won't be. So I don't know. Suppose that you wish to prove that triangle RST is congruent to triangle SRV. RST is congruent to triangle SRV. Using the reason identity, name one pair of corresponding parts that are congruent. So it's something that's congruent to itself in the sense that, if we're comparing triangle RST to triangle RVS or SRV, then these two sides are congruent. Side RS is congruent to itself. Okay? Suppose you wish to prove that triangle RWT is congruent to triangle SWV. Considering the figure, name one pair of corresponding angles of these triangles that must be congruent. So the angles in this case are going to be, okay, well, we've got vertical angles here, right? That's what they're talking about. So that's not the reason identity, though. Let's make that clear. We're saying those are congruent by the reason we would give is because they're vertical angles. And for this case here, RS being congruent to RS, that's the identity reason. That's literally the same side length, right? This isn't the same angle. They're congruent, but it's not the same angle. State which method would be used to prove the two triangles congruent. Okay, well, this would be side, side, side. We've got three congruent sides. Okay, this would be angle, side, angle. We've got two congruent sides that are included between two congruent angles. Okay, this would be, we would say side, angle, angle. Here, side, angle, angle. But remember, we know that side, angle, angle is like an offshoot of angle, side, angle. Side, angle, angle is not a postulate. It's actually a theorem because we can prove it using the angle, side, angle postulate. Because the idea is if we know that two angles of two separate triangles are congruent, then that means that the third angle has to be congruent. And so with that, then we have angle, side, angle we can use, right? We can take that third congruent angle that we didn't have initially and say angle, side, angle. That's why it's thought of as an offshoot of angle, side, angle. Okay, this is side, angle, side. So note that with all of these, okay, once we've proved congruence, then that means that we can identify all of the other corresponding features and state that they're congruent. These are the same triangle. So angle B is included between this, okay, we have one tick mark here, three tick marks here. So what's the angle that's included between the 1 and 3 tick mark? So that's these two. Those two are congruent, okay? What's the angle included between the second and third tick mark? So C and F are congruent. And therefore, that leaves A and D. Okay, here we've got, so these two triangles are congruent, so we've only got one angle left. These two angles must be congruent. Now, between this 3 mark and this 1 mark, that's these two sides, and that leaves one other side. There you go. Let's see. Here we've got, we can also use the fact that with triangles we can say, okay, the side length opposite this 2 mark angle corresponds to the side opposite this 2 mark angle. So these two are congruent. We could do that as well. That's another trick we can use. Opposite the 3 mark angle, like that. Here, so opposite this angle, we've got, that's the third side. Okay, now between mark 3 and mark 1 is these two angles, and that leaves one other angle. State why triangle ABC is congruent to triangle DBC based on the given criteria here. So triangle ABC and triangle DBC. In this case, we've got angle A is congruent to angle D. Segment AB is congruent to segment BD. And angle 1 is congruent to angle 2, which means that these are also 90-degree angles on either side, right? Now, we've also got equivalent sides here, so we actually have these two sides are congruent as well. And furthermore, we've got, since we have 2 angles are congruent, then the third angles must be congruent. So we've got a lot going on here. So with this, we could say they're congruent by angle, side, angle, but we might be able to use more than just that. We have angle, side, angle. We've got actually 2 cases of angle, side, angle. We've got angle, side, angle here, but we also have side, angle, side. So there's a lot of options here. But yeah, these are congruent, so that means the hypotenuses are congruent. Everything's congruent, right? Once you prove congruence. Okay. Same question, just a new criteria. But no matter what, with this, if we have the same figure, then these two sides are going to be congruent. Those are the same sides, right? So now here we've got angle A is congruent to angle D. We've got segment AC is congruent to segment CD. And ray CB bisects angle ACD. So ray CB bisects angle ACD, which means what they're effectively saying there is that these two angles are congruent. Okay, so we've got, in this case, we've got an angle, side, angle here. So angle, side, angle. We also have a side, angle, side. So we could do side, angle, side as well. Okay, angle A is congruent to angle D. Segment AC is congruent to segment CD. And B is the midpoint of AD. So what they're saying there is that these two are congruent. Okay, and so before saying that these are the same sides, so that these are congruent as well, just with just purely the given criteria, we could use side, angle, side here to state that the two triangles are congruent. But if we also add in this, we could do side, side, side as well. Okay, angle A is congruent to angle D again. AC is congruent to CD. And AB is congruent to BD. So side, angle, side, or side, side, side. I think this was the exact same as the previous problem, except they stated that AB was congruent to BD in a different way. Here they said B is the midpoint of AD. Here they just said AB is congruent to BD. All right, angle 1 and angle 2 are right angles, so that means they're congruent, obviously. Okay, AB is congruent to BD, and angle A is congruent to angle D. So we've got an angle side angle here. But we also could do side angle side, or another angle side angle. All right, AC is congruent to CD, AB is congruent to BD, and CB is congruent to CB by identity. So I guess they didn't want us to be officially stating that CB was congruent to CB unless we were told, but that's fine. So yeah, okay, this would be side, side, side. All right, the triangles to be proved congruent have been redrawn separately. So it's triangle ABC is congruent to triangle AED, and then they drew them separately. Name an additional pair of parts that are congruent by using the reason identity. So it's that what they're talking about here is you have the same feature on both triangles. So we can see one is going to be that, so an additional pair of parts. What do they mean by that? Oh, okay. So they've given us that AB is congruent to AE, and they've given us that angle E is congruent to angle B. But what's another pair of parts that's congruent by the reason of identity? Well, angle A is congruent to angle A. It's the same angle. Okay. Considering the congruent parts, state the reason why the triangles must be congruent. Well, we've got angle side angle. Angle side angle. So they're congruent, which means that, well, we can automatically see that the third angle has to be congruent because the first two angles are congruent. Okay, but we already knew the triangle was congruent anyway. So between the three line and the 2 line side, those correspond, and then all that's left is this. So we can see, if we want to draw this in here, angle B is congruent to angle E. Angle A is congruent to itself. Angle C is congruent to angle D. And then we can see the different side lengths, ED to BC, BA to EA, and DA to, yeah, it's hard to see in this figure, CA. Okay, same question here. So these two triangles that you have, MNP is congruent to MQP. All right, so by identity, these two sides are congruent. It's the same side. So now we've got side, side, side. Therefore, so between this 3 mark and 1 mark, these two are congruent. Between the 3 and the 2 mark, and then like that. All right, the triangles named can be proven congruent. Considering the congruent pairs marked, name the additional pair of parts that must be congruent in order to use the method named. So they're saying, okay, in this case, triangle ABD is congruent to triangle CBE, ABD, CBE, okay? And considering the congruent pairs that are already marked, name the additional pair of parts that must be congruent in order to use this method. So ABD, CBE, we are already given this here. So to use side angle side, we would have to show that this side is congruent to this side. AD, we'd have to show that AD is congruent to EC. Okay, so to show that triangle WVY is congruent to triangle ZVX, using angle side angle, and if we're already given these congruence pairs, W and Z, and this side, then we would need to show that, from there, we need to show that angle WVY is congruent to angle ZVX. So WVY and ZVX. Then we can use angle side angle. Okay, triangle MNO, triangle OPM. So here we need to show that, to use side, we need to show that these two sides are congruent. So that OM is congruent to itself. Okay, EFG is congruent to JHG. Using angle side, we would need to show that angle E is congruent to angle J. Angle E is congruent to angle J. Okay, here we're going to do some triangle congruence proofs, but we're not going to go through the official mathematical setup of stating the technical reasons for every statement we make. We're going to do these proofs informally. So, okay, given for this setup here, given that segment AB is congruent to segment CD, okay, so AB is congruent to CD, okay, and AD is congruent to CB, prove that triangle ABC is congruent to triangle CDA. So ABC is congruent to triangle CDA. Well, we can see that for these two triangles, CA and CA are the same side. So that side is congruent to itself. So we've got side. Triangle ABC is congruent to triangle CDA by the side postulate. Okay. If DC is parallel to AB, okay, and AD is parallel to BC, prove that triangle ABC is congruent to triangle CDA. Interesting. Well, okay. We know that these two sides are congruent, right? It's the same side. Now, if we have DC and AB are parallel, and AD and BC are parallel, and then they're cut, both of these are cut by this transversal AC. Well, we've got alternate interior angles here. So this angle is congruent to this angle, right, with respect to parallel lines DC and AB and transversal AC. But now if we look at parallel lines AD and BC with respect to the transversal AC, this angle is congruent to this angle. So by angle side angle, we can show that those two triangles are congruent. ABC is congruent to CDA. Okay, given that PQ bisects MPN, so PQ bisects MPN. So what they're saying there is that angle 1 is congruent to angle 2. Okay, and then segment MP is congruent to segment NP. Okay, prove that triangle MPQ is congruent to triangle NQP. So, okay, we also have common sides here. And so, okay, we can show by side angle side that the two triangles are congruent. Okay, PQ is perpendicular to MN. So that means we have a 90-degree angle here. Okay, angle 1 is congruent to angle 2. Can we now show that MQP is congruent to NQP? Okay, well, we also have this common side here. Those two are congruent. So by angle side angle, we can show that the two triangles are congruent. Okay, given AB is perpendicular to BC, so they have that shown here, and AB is perpendicular to BD, okay, and BC is congruent to BD. Prove that triangle ABC is congruent to triangle ABD. Okay, well, we have a common side here. So those two sides of the triangles are congruent. So side, angle, side. We can show that ABC is congruent to ABD. Okay, PN bisects MQ. So PN bisects MQ. That means that these two sides are congruent. Angle M and angle Q are right angles. They have that shown. So now show that triangle PQR is congruent to triangle NMR. Well, we can see that these two angles are congruent. Okay, now with that, we've got angle, side, angle criteria we can use to show that triangle PQR is congruent to triangle NMR. Okay, given angle VRS is congruent to angle TSR. So VRS is congruent to angle TSR. And segment RV is congruent to segment TS. Show that triangles RST and triangles SRV are congruent. Okay, well, they have a common side here, side RS. So we can see with that we could use side, angle, side criteria to prove this congruence, which would mean that these two angles are going to be congruent. These two sides are going to be congruent. And yeah, everything's congruent. Okay, segment VS is congruent to segment TR. All right. Angle TRS is congruent to angle VSR. So now show that triangle RST is congruent to triangle SRV. So, okay, once again, these two sides are congruent. And so now we could use side, angle, side to show this congruence. Given that triangle RST is congruent to triangle RVU, does it follow that triangle RSU is also congruent to triangle RVT? Name the method, if any, used in arriving at this conclusion. Okay. So triangle RST is congruent to triangle RVU. Then we can say that these two sides are congruent. These two sides are congruent. These two angles are congruent. Okay. These two angles are congruent. But if these two angles are congruent, then that means these two angles are going to be congruent. Because 180 minus these two, any of these angles is the same angle. So, okay, we've got, okay, let's see. Now, these two angles are congruent. These two sides are congruent. Okay, so now they're asking, is triangle RSU congruent to triangle RVT? So we can draw this. Let's see. So now comparing these two triangles directly, we can see that. So here's RSU. This side is congruent to this side, right? The double dashes RS and RV. And now the triple dashes, we've got, let's see, RT is congruent to RU, right? Now, let's see. What else do we have? So RTV, this angle is congruent to RUS to this angle. Okay, now, but we can also see that angle, so this here is angle SRU, right? And this here is angle VRT. Well, those are the same angle because angle RSU is this angle plus this angle. Angle R or angle VRT is this angle plus this angle. That's the same angle. So these two are congruent. All right. Well, if we know two angles of a triangle are congruent, then we know that the third angles must be congruent. So now we can use side, angle, side, or angle, side, angle. We can show that these are congruent, that RST No, RSU is congruent to RVT. Okay, given that angle S is congruent to angle V, and ST is congruent to UV, does it follow that triangle RST is congruent to triangle RVU? Okay, so we've got RST and RVU. So, okay, we've got that. These two sides are congruent and these two angles are congruent. Okay, what else can we show? Well, okay, if this is all of the information we have, then no, we're not going to be able to show that these two triangles are congruent. We've only got matching side lengths and a matching angle. And there's no other way we can show that, visually it looks like these two angles would be the same, but we can't say for sure. So no, without more information, there's no way we can say that triangle RST is congruent to triangle RVU. Given that angle A is congruent to angle E, and angle B is congruent to angle D, does it follow that triangle ABC is congruent to triangle EDC? Okay, well, we can see that we have vertical angles here. And if that's all the information we have, then no, we can't say for sure that these two triangles are congruent. Angle, angle, angle is not a congruence criteria. Given that angle A is congruent to angle E, again, and segment BC is congruent to segment DC, does it follow that triangle ABC is congruent to triangle EDC? Okay, so once again, these two angles are vertical angles. So here we've got angle, angle, side, and that is a congruence criteria because we've got two angles that are congruent, so that means the third angle must be congruent. The third angle pair. So we can use angle, side, angle, right? In quadrilateral ABCD, segment AC and segment BD are perpendicular bisectors of each other. Segment AC and segment BD are perpendicular bisectors of each other. So these two are congruent, these two are congruent, and we've got every angle here is a right angle. So, okay, name all triangles that are congruent to triangle ABE, triangle ABC, and triangle ABD. So, okay, we've got side angle side here. So triangle ABE is congruent to triangle and we want to get the vertices right, ADE. Okay, but now we also have, since these are right angles here as well, we've got side angle side criteria between. So, okay, also congruent. Here we've got triangle ABE is congruent to triangle CBE and triangle CDE. Okay, but now as a consequence of these congruences, let's note that segment AB is congruent to segment AD, is congruent to segment CD, and segment BC. Okay, so now triangle ABC, we can see, is going to be congruent to triangle, to this triangle. So let's get the vertices right. That's going to be triangle ADC. Right? By side, side, side. These are two equilateral or isosceles triangles. These two sides are congruent, and this common side here, you've got, so side, side, side. All right, now triangle ABD is going to be congruent to triangle, let's see, we've got, so these sides are congruent. These sides are congruent. And we have a common side here. So by side, 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 triangle ABD is congruent to triangle, let's see the vertices right, so that would be triangle CBD. in triangle ABC and triangle DEF, you know that angle A is congruent to angle D, angle C is congruent to angle F, and segment AB is congruent to segment DE. Before concluding that the triangles are congruent by angle side angle, you need to show that angle B is congruent to angle E. State the postulate or theorem that allows you to confirm the statement that angle B is congruent to angle E. Okay, well, so if we ignore this angle congruence, then we can use angle side to show that with these two angles and this side to show that the two triangles are congruent. But even before showing that the two triangles are congruent, we know that we already know that if we know that two angles of two pairs of angles of two separate triangles are congruent, the third angle must be congruent. And this just makes sense. This has to be the case. If you have A plus B plus some unknown angle is equal to 180, and then you've got the same angle plus the same angle plus some other unknown angle is equal to 180, well, those two angles are going to have to be equal. X is equal to 180 minus A minus B. Y is equal to 180 minus A minus B. So either from angle side, showing that the two triangles are congruent, so everything's congruent, or just from the fact that we know that if we found that two angles of two separate triangles are congruent, then that means the third angle must be congruent as well. We can confirm the statement that angle B is congruent to angle E. Okay, given plane M, and C is the midpoint of EB, so these are congruent. AD is perpendicular to BE, so like that. And AB is parallel to ED. So these two are parallel. Prove that triangle ABC is congruent to triangle DEC. Okay, well, if these two are parallel, then we have a transversal that connects those two parallel lines here. And with that, we've got alternate interior angles here. So these two angles are congruent. Okay, well, we also know that this is a right angle. Okay, we've got two matching angles here between these two triangles that are congruent. So these two angles must be congruent. So by angle side angle, we have congruence of triangles ABC and DEC. Okay, given segment SP is congruent to segment SQ and segment ST is congruent to segment SV, prove that triangle SPV is congruent to triangle SQT and triangle TPQ is congruent to triangle VQP. So, okay, we've got, let's separate these out. Triangle SPV and then triangle STQ. Okay, so SPV, STQ. All right, then we've got triangle PVQ and triangle PVQ. So, okay, we've got VQP. Okay, so SP is congruent to SQ. ST is congruent to SV. All right, that's all they give us. Okay, but angle S is congruent to itself. So by angle or by side angle side, we can show that this congruence holds. These two triangles are congruent. So with that, we can go ahead and match up the rest of these features. Between the 3 and the 2, we've got, okay, so there we go. All right, so now PV is congruent to TQ. PQ is congruent to itself. And okay, what we can also deduce is that, so if these two angles are congruent, then these two angles must be congruent because they're both relative to the same horizontal line. You see, again, if these two angles are congruent, then these two angles are going to have to be congruent. The whole angle is going to have to be congruent. So these two angles are congruent. So we have side, angle, side. So that shows that these two triangles are congruent. Okay, given angle ABC, all right, RS is the perpendicular bisector of AB. Okay, RT is the perpendicular bisector of BC. Okay, they've indicated these congruences for us. Prove that segment AR is congruent to segment RC. AR is congruent to segment RC. Okay, so we've got a common side here. RS is congruent to itself, right? And here's a 90-degree angle. So by side angle side, triangle ASR and triangle BSR are congruent. So this side is congruent to this side, and this angle and this angle are congruent, and this angle and this angle are congruent. Okay, now let's see. We've got two right triangles here. We've got a common side here. All right, so side, side, side. These two triangles are congruent. So these two. So, okay, that means this is congruent to this, but this is congruent to this, so AR is congruent to RC. There you go. You see, there's 4 tick marks. There you go.